Hello, welcome to today's class on understanding geography with diagram. Today we'll be talking about the monsoon mechanism. Now basically we have two approaches to monsoon mechanism, the classical and the modern. Prior to going to the approaches, let us understand what do we mean by your monsoon. Monsoon is nothing but the seasonal reversal of the wind. It is the seasonal reversal of the wind leading to the precipitation over the landform. Now, how does this seasonal reversal occurs? We'll go one by one. First of all, let's understand the classical approach. The classical approach was given by two of the scientists. One was the Hadley, the climatologist, and another one was Flon. As per Hadley, what he says is that, see, this is your landmass. Hadley says that when the landmass gets heated, there is a hence the landmass will develop a low pressure and consequently the sea will develop a high pressure. Therefore, the air will flow from the sea towards the land, and this happens during the time of your summer. And during the time of the winter, the opposite happens. What is the opposite? It means high pressure over here, low pressure over here. Hence, see, now this he so basically what he said is that Hadley says that during the summertime, when there is a low pressure on the land and high pressure on the sea, and the winds moving from there to here, he called this as the southwest monsoon. On the other hand, when during the winter time, when there was high pressure on the land and the low pressure on the sea, there was reversal, and he called this as the northeast monsoon or the this northeast winds. So basically, he said that the southwest monsoon was nothing but the onshore winds, and the northeast is nothing but your offshore wind. Now, Hadley made a significant mistake over here. What was the mistake? Hadley never took into consideration the movement of the sun that was responsible for this thermal heating. Apart from that, there were also other mechanisms that were involved. Now, Flon made a certain improvement. Flon says that what happens is that during your summer solstice, there is a shift of the sun over to the Tropic of Cancer. Hence, this is also your location of your ITCZ, and it is the development of the ITCZ over this landmass results in the incoming of the southwest monsoon, which crosses the equator. After it crosses the equator as the southeast monsoon, it becomes southwest, because in the northern hand side, as we know, it is due to your Coriolis effect, it will move towards the right. Now this was the Flon's concept. Again, Flon missed out many of the things that were associated with the monsoon. Hence came the modern approach. Now modern approach basically pinpointed out how exactly which landforms were responsible for bringing the monsoon, how the low pressure develops, where the low pressure develops. This was brought in by the modern approach. Hence, in the modern approach, we'll talk about the role of the Tibetan Plateau, the ENSO, that is the El Nino Southern Oscillation Connection. We have the Indian Ocean Dipole Moment and the Mid-Julian Oscillation. Now, basically, we'll start with your role of the Tibetan Plateau. Now, understand this role of the Tibetan Plateau with the help of a diagram. Tibetan Plateau, see, your Tibetan Plateau is almost over here. The Tibetan Plateau is over here. So what happens is that, first of all, we know is that the ITCZ will develop over a low pressure zone over here. The ITCZ will develop an exceptional bend over here. As in the last class we had said, development of the exceptional bend of the ITCZ will lead to the displacement of, it will displace what? It will displace your subtropical jet stream and will establish what? The tropical easterly jet. This tropical easterly jet will have north-south orientation. Let us understand in the vertical manner. It's simple like this. This is your Himalayas. beyond the Himalayas. Beyond the Himalayas, we have the Tibetan Plateau. The ITCZ located over the Tibetan Plateau will develop what? Low pressure. With the development of the low pressure, that would be what? On the top. On the top, we'll have a high pressure. And to the nearing ocean, obviously, since it is cold, it's have a high pressure. The high pressure is nothing but called as the mascarene high. This mascarene high prevails over your Indian Ocean. So what happens is that the low pressure that develops over here will result in the high pressure at the top. Similarly, the high pressure that develops over the mascarene high will result in the low pressure over. So look, from the low pressure it will move to high pressure, and from the high pressure it will move towards your low pressure zone. And from your high pressure it will obviously move towards your low pressure. Now, what basically you saw is that, so this is your Himalayas. So basically what happens is that it is your taller Himalayas that will obstruct this. Not just the Himalayas, but again we have the Western Ghats that keeps obstructing and basically results in the monsoon. Now what happens that it is because of this Himalaya and because of the other topographic feature that the monsoon wind does not escape the Indian landmass. Hence it gives rain in the Indian landmass. Basically, if it would have escaped Indian landmass, then it would have resulted in the desertification of the Indian landmass. I hope you got that. Next, this is your role of the Tibetan Plateau. Next, let's understand the ENSO. What is this ENSO? ENSO is nothing but your El Nino North-South oscillation. Let us understand this by a diagram. This is your Indian Ocean. This is your Pacific Ocean. Now let's understand this. Basically, please just hold on a second. Let me check my when I have switched on my microphone. Yes, the microphone is on. Now, see, basically we know that the western part of the South American continent is dominated by your Peruvian current. It's the cold Peruvian current. Now what happens that when the ITCZ is placed over the Indian Ocean, what happens over here? We develop over here a very big low pressure trough. Last I have said that trough is nothing but an extensive low pressure area. Now this development of the low pressure trough will, what it will do? It will attract winds. Wait, first let's draw the equator so that you can see. It will attract the winds. This will attract the winds that will cross. See, the wind's direction is changing, that is from southeast to southwest. Now this orientation, that is the prevalence of a high pressure over the Pacific Ocean and a low pressure over your Indian Ocean. This is your Indian Ocean. This is your Pacific Ocean. High pressure over the Pacific Ocean and the low pressure of the Indian Ocean will lead to the cell, and this cell is called as your modified Walker cell. Sorry, it's not your modified Walker cell. It's simply called your Walker cell, not modified. This is your Walker cell. And please understand this, and this cell that you see over here, it is nothing but your That is the prevalence of a low pressure zone over here is nothing but your Headley cell. What is the Headley cell? Headley cell is simple. Headley cell is that key that there is a prevalence of the low pressure area over where in the Indian Ocean. That's your modified Headley cell. It will be your modified Headley cell. It is the Walker cell, that is the prevalence over here, this high pressure over here, and the modified Headley cell, that is prevalence of the low pressure over here, will result in what? Will result in the smooth transmission of the air, that is from your Pacific Ocean towards your Indian Ocean, hence resulting in the monsoon in the Indian landmass. Now what happens is that sometimes the La Nina, the El Nino, the La Nina, the cold Peruvian current is called La Nina, is replaced by El Nino, that is your warm current over here in the Pacific. And this warm current results in what? It will result in the reversal of the wind. Means the winds will not move anymore towards over here. Rather, the direction of the winds will change. That is, it will move towards here, hence causing precipitation where? On the South American continent, and there will be completely dryness over here in the Australia, India, Africa, the Horn of Africa, this part of the region. This will be completely dry, but on the other hand, there will be precipitation over the South America. Now this kind of the condition where there is a prevalence of your low pressure in the Pacific Ocean results in the formation of your modified Walker cell. So what you came to know is that the El Nino results in the modified Walker cell, hence resulting in your drought. It's drought over Australia, India, and Southeast and certain parts of East Asia. Now what happens with the La Nina? La Nina means, this is your cold current, this is your warm current. Where are they prevailing? In the western coast of the South America. La Nina means Walker cell, hence precipitation over Indian subcontinent. I hope you got the connection of the answer. Next, let's go back to your Indian Ocean dipole moment. So, Indian Ocean dipole movement. Now, what is this Indian Ocean dipole movement? It's very easy. Just understand this. See. Sorry. The Indian Ocean dipole moment, let's understand, we'll categorize it into two categories. One is your positive dipole, another is your negative dipole. And this is a positive dipole. This is a positive dipole and negative dipole. Let's understand when is the condition of a positive dipole and when there is a condition of a negative dipole. The condition over the positive dipole is when there is the prevalence of the warm water in the Western Indian Ocean. This is basically your Indian Ocean. Prevalence of the warm water over the Western Indian Ocean. What will happen if there is warm water prevailing over the Western Indian Ocean? Hence, it will develop a low pressure in this side, resulting in the attraction of the wind, and that the wind will cross again and results in the precipitation of the Indian subcontinent. So Western positive dipole movement means there is a warm water prevailing in the Western Indian Ocean. What is the negative dipole? Now negative dipole is obviously the opposite. Means the warm means this part, the Western Indian Ocean is cold, whereas the Eastern Indian Ocean is warm. And what it will do? It will do nothing but the reversal of the winds again. And hence the Indian landmass will suffer from drought. It's a drought over the Indian landmass. Now what we have understood over here is that it is sometimes even your El Nino, that is El Nino phenomenon, is cancelled out by the positive dipole movement. There are in certain years what happens is that even if there is a prevalence of El Nino, it's the positive dipole movement that actually cancels out the effect of El Nino by having the warm water in the western part. I hope you got the Indian dipole movement concept. Next to the Indian dipole movement concept we have here is the mid-Julian oscillation. What is this mid-Julian oscillation? Simply understand that the mid-Julian oscillation is nothing but a flow of low pressure trough from west to east. It is a low pressure trough that keeps following from the west to east. See, if the mid-Julian oscillation occurs over the Indian Ocean, what will happen is that it will converge over the Indian Ocean. Hence, the air will rise, resulting in your precipitation. But what happens if it converges over the Pacific Ocean? See, this is convergence over the Indian Ocean and convergence over the Pacific Ocean. Now, if the mid-Julian oscillation converges over the Pacific Ocean, what will happen is that it will change the pressure gradient. Like same over here. If if the mid-Julian oscillation is converging over the Indian Ocean, what will happen is that low pressure will develop over there, and as a result, the winds will be attracted from here, that is from the Pacific and the surrounding, and hence resulting in the southwest monsoon. But think of the situation when it does not converges over here, rather it converges over here in the Pacific. So what will happen? Low pressure over the Pacific, resulting in that the reversal of the wind means the wind will move towards the Pacific Ocean, hence drought in the Indian Ocean. So these are the following four. So basically what we got is that the monsoon mechanism, the approaches to understanding of the Indian monsoon or the monsoon over the Indian subcontinent, we can have two approaches, the classical and the modern approach. With the classical approach, we have to go for the Headley, the Flon, and with the modern approach, we have to go for this role of the Tibetan Plateau, the Enzo, IOD, and the mid-Julian oscillation. Notes have been given, please refer to them. Thank you.